this example, once again there is a body of mass m, point mass body. The length is r, it has been released from here, and this oscillates in a vertical semicircle. And we are asked, what is the tension in the string at this instant? When this body reaches over here, then what is the tension? So if we see, that is now the two steps we have done, we know that is how to find all the heights from this reference level. We have done it, and we have also done how to use the conservation of mechanical energy principle to find the velocity or speed at any instant. So what we do is, that is using the conservation of mechanical energy principle, we know velocity over here and we can find the velocity over here at this point. Let's call this as point A and call this as point B. So this is VB over here. So using the conservation of mechanical principle between these 2 points, we can find the velocity at B. This can be found out. So once we find the value of VB, so then A centripetal is going to be V square upon R. That is VB square upon R. That is the value can also be calculated. Once VB is calculated, then centripetal acceleration is also calculated. It means centripetal acceleration is also calculated. I remove this B and I remove this M also, so that it doesn't get cluttered, and we can focus primarily on some important things. So centripetal acceleration is now towards center. Now how to proceed further? When centripetal acceleration is here towards center, it means we also know the value of mv square upon r. So centripetal force can also be calculated. Now comes, that is, who is going to supply this force? Who is going to meet this requirement? For that, we'll look at the forces, real forces, which are acting on this body at this instant. At this instant, there are 2 forces. One is tension, if we take this as a free body. So tension is always away from body towards this, that is towards center. And mg is always going to act vertically in this direction, vertical downwards. mg is always vertical downwards. So now we see that is tension is already a radial force along the radius. But mg is not along the radius. So what to do? In all these cases, what you do is, you do not disturb the forces which are already aligned along the radius. Please do not disturb the forces, because eventually we have to find the centripetal force. This force is already aligned along the radius, so do not disturb those forces which are aligned along the radius. Break those forces into the components which are not aligned along the radius. Like mg is not along the radius, mg is this way. So you have to break mg into its component. And now how mg can be broken? Break mg or the force which is not along the radius in such a way that one of its components is along the radius. So if one component is along the radius and we are talking about the rectangular components, then certainly the other will be tangential. So one is this component, the other is this component. We can make x and y axis over here, and from here we see that if this angle is theta, this and this line, they are parallel, and this is transverse. If this is theta, so this is also theta. If this is theta, so from here to here it is 90, so this is 90 minus theta. And its components, these are 2 rectangular components. It means this angle total is 90. So if this is 90 minus theta, so this angle is theta. That is, if this angle is theta, this angle is theta. So we can remove this so that there is no confusion. If mg is like this, then this component is now going to be mg cos theta, and this component of mg is going to be mg sin theta. This was the force, resultant force, and this we have broken into its components. Either we can have a force or we can have its components. Now we remove this force because this force is now being represented by its components. Mg sin theta this way and mg cos theta is this way. Tension is this way. Now along the radius we have 2 forces, one is T, the other is mg sin theta. Ultimately this body is accelerating toward the center, that is centripetal acceleration towards center is v square upon r, and centripetal force is mv square upon r. This we have calculated. So now there are two forces only which are along the radius. One is T, that is mv square upon r, that is a requirement. And now what are the forces along the radius? One is T, the other is mg sine theta. Ultimately the net force has to be towards center, and these two real forces only, they have to meet the requirement, this requirement, what is required by this body, which is revolving in a circle. So it is T has to be greater than mg sine theta, that is T minus mg sine theta, that has to be equal to mv square upon r. Angle is given, and please be clear whether this angle is theta is given with this horizontal or with vertical. Accordingly the components they will change, and you can find the value of T, because mv square upon r is known, theta is known, m is known, g is known, so this is known, so tension you can easily calculate. So T minus mg sine theta is equal to mv square upon r. What about this force mg cos theta? There is also a force. What we see over here is when the body is coming like this is not a case of uniform circular motion. This is a case of non-uniform circular motion. As it is coming down, it is losing on the potential energy, the height is reducing, potential energy is getting lost, and kinetic energy is increasing, that is speed is increasing. When speed is increasing, it means speed is changing. When speed is changing, it means a non-uniform circular motion. And in non-uniform circular motion, in addition to centripetal acceleration, there is going to be tangential acceleration also. If there is tangential acceleration, there has to be a tangential force. This is the tangential force in this case. That is, if we say tangential force at this instant, what is that? Tangential force is mg cos theta is a tangential force. Tangential force is mass into acceleration, that is tangential acceleration. Obviously you will get tangential acceleration only. With the tangential force you can find only tangential acceleration only. So A tangential comes out to be g cos theta. So this is the tangential acceleration. And what is the centripetal acceleration towards center? It is v square upon r. At this instant, this particle, this body, it has two accelerations. One is AC over here, that is centripetal acceleration over here. The other is AT over here, and the angle between the two is 90 degree. So if we redraw this over here, so one is AC towards center and the other is AT over here. So net acceleration is somewhere in this direction, which you can easily calculate. That is A net is equal to vector sum of these two, that is AC square plus AT square. You can find the value, and if you have to find the angle alpha also, then also you can easily find using vectors, etc. You can find the value of this angle alpha. So whenever the body is moving in a circle, first thing is find out whether this is uniform circular motion or non-uniform circular motion. If it is uniform circular motion, there is only going to be centripetal acceleration. But if this is going to be a non-uniform circular motion, as the case this was, there are going to be two acceleration. One is centripetal acceleration, the other is tangential acceleration. There are going to be two accelerations, and the net acceleration is going to be vector sum of these two. Also in cases like this, do not disturb the forces which are already along the radius, and break those forces into components which are not aligned along the radius. Break those forces in such a way that is one of their components is along the radius and the other will be tangent to the circle. Centripetal acceleration is also known as normal acceleration or radial acceleration. That is, whether you call as centripetal acceleration, or you call it as normal acceleration, or you call as radial acceleration, all mean one and the same thing, and the value being v square upon r.